Alright, we're starting another recording. Starting 5.4, talking about polynomials. Starting another recording, talking about 5.4, talking about polynomials. Let me see how this goes and go from there. What is a polynomial? That is the question. A polynomial, by definition, is an expression. And I just went blank as to what a polynomial is, of course, because I'm being recorded. So, of course, I went blank, of course, too much like right. It is an expression that is a single term or sum or difference of multiple terms. With numbers and variables with whole number exponents. There are no variables in the denominator. Sorry, I went blank there. I do apologize. There are no variables in the denominator. And for those of you who cannot read that, let's write it over here. Denominator. Alright, let's move forward. Moving on then to talk about, well, what is a term then? A term is the product or quotient of numbers with variables and exponents. And exponents. So the term is a product or quotient of numbers with variables and exponents. In a polynomial, terms are separated Now, I might have spelled separated wrong. I apologize. Terms are separated with plus, with addition, and or subtraction. Let's look at, for example, an example if I just wrote x squared plus 3x plus 4. We have what we call a leading term. The leading term is the term with the highest power. Or degree. And we'll talk about degree in a minute. But the leading term is the term with the highest power or degree. This 4 right here, we call this 4 right here, we call this a constant term. And I feel like we've talked about this at the beginning of the semester, but just want to reiterate as to what it is. That is our constant term. Well, what is a degree of a polynomial? The degree, and I'm just going to put arrows so we know main ideas. Just going to go back and put arrows so we have some main ideas here. Give us some type of organization in our notes. So, a degree. What is a degree per se? The degree of a polynomial it is the highest sum of exponents in any one term. So it is the highest sum of exponents in any one term. So we classify based on this idea. So if I had, for example, 3x squared y to the third plus 3xy squared plus 3y to the third. if you look at the sum, you'll see that the sum of exponents here, this degree of this term is 5. This term here, the degree, so we're talking about the degree here, is 3, because that's a 1. And this one is also 3. That means that this is, because it's a 5, it is a 5th degree polynomial. Now, why do I need to know all this? Why do I need to know all this? Because we classify polynomials based on the degree and the number of terms. So we classify polynomials based on the degree and number of terms. One term is called a monomial. 2 terms is called a binomial. 3 terms is called a trinomial. And 4 or more terms, it essentially is what it is, and that is a polynomial. Please know that monomial, binomial, and trinomials are also polynomials. They just have specific names based on the number of terms that they have. I'm going to be on page 383. So we're going to be on page 383, looking at our exercises on page 383. I'm going to look at number 18. It wants us to classify each polynomial based on, is it a monomial, a binomial, a trinomial? And I would like to also look at the degree as we move forward. Also looking at number after 34 through 48 asks us to find the degree. But let's start with number 18 just to get us going. 18 is this 3y minus 5. So I would do 18, 3y minus 5. Well, this has 2 terms. So that tells me that this is a binomial because it has 2 terms. 1, 2. So there's 2 terms. Let's look at number 22. 22 says 3 over 5, x to the 4th, minus 2 over 5, x to the 3rd, plus 3 over 5, x minus 1. How many terms does this have? This has 1, 2, 3, 4 terms. So technically this is just a polynomial, and they have it listed as none of these. So make sure that you read the question carefully, especially when you're doing your web assign. Make sure you're answering the question that they ask. Let's look at number 26. I have 2x cubed minus 5x squared plus 6x minus 3. Again, how many terms do we have? We have 4 terms. So that's just a polynomial. Let's look at number 30. Actually, you know what? I'm not going to do 30. I changed my mind. Let's do number 32. No, we did binomial already. Let's do 24. I'm going back to 24. 12z to the 4th. Well, how many terms do I have here? This is just 1 term. So we call this a monomial. And I'm getting ready to do something that I normally don't do, which is an odd problem. Let's do number 19, which is y squared plus 4y plus 3. So we have y squared plus 4y plus 3. I have 3 terms here, so that tells me I have a trinomial. So now we're going to look at, that's just knowing the number of terms. Now we're going to look at the degree. We're going to look at the degree. So we're looking at the degree this time. And we're going to look at number 34. It has 3x to the 5th. So if I take 3x to the 5th, the highest power I see here is a 5, so that means this is a 5th degree. If I wanted to fully classify it, we would call it a 5th degree monomial because it only has 1 term. But they didn't ask that, they just asked for the degree, so we follow the directions. Let's do 38. I've got 1/2 y to the 3rd plus 4y squared. The highest power we see here is a 3. So that tells me that this is a 3rd degree. And if I wanted to complete the classification, I would say the third degree binomial. Binomial because it has two terms. So I would say third degree binomial. But we're not saying that because we don't want to, again, change up the directions. Let's do number 42. 42 says 17, ab to the fifth, minus 12, a to the third, b. And I hope you're noticing that those are b's and not sixes. So just want to make sure you don't think that's a 6. So, again, remember that the degree is the highest sum of the powers and in the term. So if I look at the sum of the powers here, there's a 1 there, so that means that's a 6. There's a 1 here, that's a 4. What's the highest power here? The highest sum is the 6, so that means that this is a 6th degree. Degree binomial. That's a 6th degree binomial. All right, let's do one more. Let's do 46. I've got 7/8 t to the 10th minus 1/8 t to the 16th. It does not matter that it's on the right hand side. It still has the highest power. Doesn't matter where it is, it's the highest power that matters. So this is a 16th degree binomial. It technically is still the leading term. Okay, so that's how we classify polynomials, by the degree and the number of terms. So let's move forward and let's talk about how to evaluate. To evaluate a polynomial. Hello. What do you think we're going to do? We're going to PNC. What does PNC stand for as a reminder? Plug it and what? Chug it. You got it. So let's go to work. Plug it and chug it. Plug it and chug it. Let's write it down. I've got negative 10.3 x squared minus x plus 6.5. And we want to plug it in for x equals negative 1. So essentially what we're doing is we're going to plug in a negative 1. Make sure you put it in parentheses so that way it doesn't make any mistakes. So I get negative 10.3, negative 1 squared minus a negative 1 plus 6.5. Well, negative 1 squared is just 1. So that becomes negative 10.3. Two negatives make a positive, so that's plus 1 plus 6.5. So now you get your handy dandy calculator. And let's see what this is. And of course, you know, my smart self, I closed it. So I've got negative 10.3 plus 1 plus 6.5. And I end up with a negative 2.8. So we have a negative 2.8 as our answer. So let's try. So that is how we evaluate. Let's try letter B. B asks us to do it when x is negative 2 this time. Same math, except it's a little bit more complicated because the numbers are changing. But it's still the same math. We get negative 10.3 times a negative 2 squared minus a negative 2 plus 6.5. But writing it down first is a big deal. Writing it down so that way I don't make mistakes is a huge deal. When I square negative 2 squared, doesn't this become a positive 4? Not a negative 4, a positive 4. So I'm going to type it in my handy dandy calculator. Negative 10.3 times 4. These two negatives make a what? Positive. So that's plus 2 plus 6.5. And we end up with a negative 32.7. So that is how we plug it and we evaluate a polynomial. Now let's talk about graphing a polynomial. Graphing a polynomial. And as usual, to check our polynomials, we always want to use Desmos. We can check our polynomial by using Desmos. So we can check our polynomial by Desmos, but we're going to do it first, and then we're going to check it using our Desmos. To graph a polynomial, excuse me, we're going to make a table. Now when we're dealing with a polynomial, a lot of times you want to pick like 5 values. You want to pick 5 values, and that helps us get a better sense of what's going on. I'm going to be looking at number 76. And I'm looking at y equals x to the third plus 4. So I'm going to get me a table going. Here's x and y, and we already know how to graph using a table. Instead of looking at just 3 values, which is what I told you for a line, I'm going to look at 5 values. So I'm going to go -2, -1, 0, 1, and 2. And we're going to plug it in. So -2 to the third plus 4 is a -8. So -2 to the third plus 4 is a -8 plus 4, which is -4. -1 to the third is a -1 plus 4 is 3. 0 to the third, that's just 4. 1 to the third, that gives me 5. And 2 to the third is 8 plus 4 gives me 12. Now let's graph it. Get us a handy dandy graph going. Remember, every graph has to have what? It has to have an X, a Y, and a 0. Every graph has to have an X, a Y, and a 0. So let's go to the left 2 and down 4. Put a point. I'm going to go to the left 1, up 3. I hope I did that right. -1 cubed. Yep, I did. 1, 2, 3, -1. Put a point. Go 0, 4. That's up 0, 4. Oops. Put a point. 1, 5. So that's up 1 more. Put a point. And then 2, 12. So that'll be 2. And a 6, 7, 8, 9. Not long enough. 10, 11, 12. Put a point. So our graph becomes looking like this. And that is called a cubic technically, because of this cube being our degree. This is the cubic graph, and you'll learn that in 1150, looking at families of different types of graphs and different types of functions. But let's look at this on our Desmos and make sure we get the same thing. Let's go to our Desmos. You have it on your phone, or you can look at your calculator. On your computer, you can do this on the computer. So we're doing x to the third plus 4. When we do that, if I bring this down, we'll see that point of -2. We'll see that point of -2, -4. I got issues, y'all. So you see -2, -4. Then we see that point of -1, 3. Then we see the point 0, 4. Then we see the point 1, 5. And then we see the point 2, 12. And of course you can go more points than that, or even small. I'd rather you not do less than that, because when we do polynomials, you want to have at least 5 points. Alright, that takes care of 5.4. Let's move on then to 5.5. So that takes care of 5.4. Now let's move on to 5.5. 5.5 is adding and subtracting polynomials. So essentially, graphing using a table is really just a plug and chug problem. You plug the value in that you're picking for x, find the value y, and then plot it on a coordinate system, remembering which way to go, left, right, up, down, etc. Making sure your quadrants is in the right spot. So let's talk about adding and subtracting polynomials. To add and subtract polynomials, the main idea is CLT, and we know CLT stands for combine like terms. They must have the same variables with the same exponents. You cannot add x squared plus x cubed does not equal x to the fifth. This is voodoo algebra. You took your wand, you thought you were Harry Potter, Hermione Granger, Luna Lovegood, Ron Weasley. You thought you were one of them, and you even might have thought you were Voldemort. But you decided you were going to take your wand and say this is what it's going to be. No. That is voodoo algebra. You cannot do that. That is voodoo algebra. So let's see what it is. There are 2 ways to do it. We can do it vertically or horizontally. It does not matter which way we do it. We can do it vertically or horizontally. Let's try horizontal first. Essentially the same thing. We're going to just be combining like terms. So if we do it horizontally, we have 16. What number we're going to do? The number we're going to do is 18. Let's do 18. So let's do -3y squared minus y minus 6y squared plus 7y. So we're doing negative 3y squared minus y minus 6y squared plus 7y. What is like here? What are the like terms here? Well, I'm going to start off with my highest power first. Do my highest power, my leading term first. My highest power is 2. So I'm going to pick these two. What's a negative 3 and a negative 6? We're just combining them. That is a negative 9, and then the y squared stays along for the ride. Now let's do the next one. So when I get done with it, I like to cross stuff out so that way I don't make a mistake. So when I get done with it, I cross things out as I go so I don't make mistakes. Let's do the second term. I've got a negative y and a plus 7y. Well, negative y and a positive 7y gives me a plus 6y. And guess what? That's it. And I'm done. That's it. Let's try number 34. Let's try number 34. 34. Well, what does 34 say? 34 says negative 0.3r minus 5.2s. You know I like s's, so I'm going to do x. Plus 0.8r minus 5.2x. Again, remember, what are we going to do? Essentially, what's in front of the parentheses here? Because that's what I normally would do. When we simplify expressions, we normally get rid of our parentheses first. Is that right? I'm trying to make this brighter as much as I can. This is getting interesting in terms of being brighter. Doing my best to make this as bright as possible. I'm concerned about you being able to see the screen. So what do we normally do when we have this kind of situation? I wonder if I turned off a couple of lights, would that help it out? I don't know. That'd be interesting. I might try that the next time we do another video. I'll try that then. Not now, then. So here we go. Let's go to work. So if we combine like terms here, there's parentheses in the way. Well, number in front is a 1 here and a positive 1 there. What does 1 do to the inside? Absolutely nothing. So essentially you can write this all out at one time. It's essentially, it just stays the same. Now when we subtract, we're going to see that it's going to actually change things. But for addition, it just stays the same, and we do what we normally know to do, and that is combine like terms. What's likes here? Well, I see the r's are alike, because there's no powers to play with. So now, I'm just going to look at the r's being alike, doing it in alphabetical order. Negative 0.3r plus 0.8r gives me a 0.5r. Cancel, goodbye. Now move on to the next one, the x's. Well, a negative 5.2 and a negative 5.2 is just a negative 10.4x. And that's it. That's it. All right, let's try another one. Let's make it a little bit harder. Y'all know how I am. I love to make stuff a little harder. Let's do 38. Let's do 38. We're going to have, they want to find the perimeter. Well, we know to find the perimeter just means the sum of the outside. So we're going to essentially add up all the sides. We know peri, it means around, and meter means measure. So when we talk about perimeter, we're measuring around the object. So it means add up all the sides. So let's go to work with it. Let's take 2y to the 5th minus 3y to the 3rd. This honestly would be nice vertically, but that's okay. We're going to do it. Plus y to the 5th plus y to the 3rd plus 5y to the 5th minus 5y to the 3rd. Okay, same way. Again, pause it, you try. You pause it and you try. But I'm going to keep going because we're videotaping. But you should pause it and try it. So I'm going to combine like terms. I'm going to start off with the highest power, which is 5. And I'm going to see that I see 2y to the 5th, y to the 5th, and 5y to the 5th. Well, that ends up being 8y to the 5th. Okay. So I'm done with that, so I'm going to cross it out. Now move on to the next thing, which is a negative 3, positive 1, and a negative 5. Well, negative 3 and a negative 5 is negative 8. Plus 1 is a negative 7, y to the 3rd. Remember, addition is commutative. Addition is commutative. That means a plus b is the same as b plus a. I can change the order. And it's also associative. It's up to me to change the order. So we've talked about how to do this horizontally. Oh, and don't forget your units. It's inches. Don't forget your unit. Quarter point is inches. But we talked about how to do it horizontally. Now let's talk about vertically adding. So we're going to vertically add. The key thing to vertically is you need to line up like terms. That's essentially what it is. It is lining up the like terms. And once you line up the like terms, you just add down. So let's go to work with it. I'm going to line up the like terms. And I'm going to do number 44. Going to do what number? 44. So let's take negative 2c squared minus 3c minus 5 over 14c squared minus 1. And we're adding. So we're adding like terms. Literally, notice that I put my c squareds on top of my c squareds, my minus 1 over my minus 1, and c has nothing else to be with it. So it's by itself. So notice that the terms are lined up. It makes life a whole lot easier. I can literally just add straight across. I literally can do this left to right. I really don't have to do it right to left. But for practice sake and habit's sake, we normally start on the right. Negative 5 and negative 1 is a negative 6. Negative 3c just comes along for the right. And negative 2 plus 14 is 12c squared. And guess what? I'm done. Vertically a lot of times makes stuff a lot simpler. It makes stuff a lot simpler. Okay, so let's do number 52. We're going to talk about subtraction this time. Let's do number 52. We're going to talk about subtraction this time. So before we were doing adding, now we're going to do subtracting. So subtraction, if we move on to subtraction with number 52, we have to look at something when we do it. And I have negative c to the 5th plus 5c to the 4th minus 12 minus 2c to the 5th minus c to the 4th. Again, remember our first step of simplification is usually clear the fraction. But our next step is to get rid of those parentheses, distribute. So essentially we need to find out what is in front of my parentheses. Well, if I look at that, in front of my first parentheses, it's a positive one. But in front of the second parentheses, we have a what? Negative one. So we have to be very careful when we distribute there. So if we distribute the first positive one, the thing just stays the same. So I end up with negative c to the 5th plus 5c to the 4th minus 12. This is where people get messed up. They forget they need to distribute that negative one to both of those. And so by distributing that negative 1, I end up with a negative 2c to the 5th. But this becomes now a positive c to the 4th. Once we distribute that, now we can combine like terms like we normally do. But first we have to distribute and get rid of those parentheses. And distributing the 1, this doesn't really change anything. It just stays the same. But the second one, it changes the signs to opposite. So let's go to work. Combine like terms. Start off with my c to the 5th. And I end up with a negative 3 c to the 5th because a negative 1 and a negative 2 is a negative 3. So I'm done with that. Then I go to my c to the 4th. 5c to the 4th and the c to the 4th is plus 6c to the 4th. Notice the signs are what I want them to be. And then a minus 12. And that's it. That is it. Okay, so let's talk about vertically this time. So now let's do a vertical problem, doing this idea vertically. Before I do that, I want to talk about something else. We're going to do it, we're going to like kill two birds with one stone. So let's kill two birds with one stone. Let's do number 62. It says subtract, I'm going to write it out on purpose, m to the 3rd plus 20m squared minus 15m plus 39 from minus 4m cubed minus m plus 22. Because I'm subtracting this blob here from this blob there, then that means which one goes first? This goes first because I'm taking it from the minus 4m cubed minus m plus 22. So when I light this up vertically, I'm going to start off with the negative 4m cubed. I'm going to leave a little space because I don't have an m squared, minus m plus 22. This is space for the m squared because I don't have it. So I'm going to leave a little space there. Then the next line, I'm going to put my m cubed under my m cubed. I'm going to put my 20m squared under the m where the space is, minus 15m and plus 39. I'm killing multiple birds right now with one stone. Notice I got this big subtraction sign. Remember a long time ago when we were talking about positive and negative numbers and we were talking about integers and we were dealing with plus and minus? When we were dealing with this a long time ago, remember that every minus sign can be written as a plus negative. Every subtraction can be written as a plus negative. So this becomes a plus, but then we have to distribute that negative through, just like we did up here. When we did it here, remember we had to distribute the negative 1 through the second one? Same thing here, except we're going to do it down here. Now we need this coming up down the road when we do long division, and that will be in 5.8. So we're going to need this down the road for 5.8. So make sure you pay attention to this. When distributing that negative, we're going to make everything change the sign. So essentially all we're doing is changing the sign to everything. So when distributing, that negative 1, essentially we're just changing the sign. And that's what we're going to do when we get to long division. We need this down the road. Remember, I never teach just right now. I'm always teaching down the road. So now that everything's lined up, it's kind of looking leaning. It looks like the Leaning Tower of Pisa, but we can handle it. Let's go to work. What's 22 and a negative 39? Well, that's a negative 17. Positive m and a plus 15m, that's 16m. Nothing in a negative 20m squared is a minus 20m squared. Oops, that's a plus 16m, sorry. And negative 4m cubed and a minus m cubed is a negative 5m cubed. And guess what? I am now done. A lot of times you can do this from left to right and it makes it a whole lot easier when you're writing it out. But it's up to you. Okay. Well, we just killed like 2 birds with that. So you might want to rewind, replay to make sure you understand what we're doing. Again, you might want to rewind and replay to make sure you understand it. I'm going back to horizontal right now, because I want to do this problem on number 68, which is kind of interesting. It says subtract negative 3z cubed minus 4z plus 7 from the sum of 2z squared plus 3z minus 7 and negative 4z cubed minus 2z minus 3. I'm challenging you right now to pause the video and see if you can figure out how to set this up on your own. I'm challenging you right now to pause the video to see if you can set this up on your own. I'm challenging you to pause the video and see if you can set this up on your own. Wow, I've done a lot of pages today. I challenge you to pause the video and see if you can set this up on your own. Let's go to work with it. The sum. Remember it says subtract from. If I'm subtracting from, that means that this goes at the end. Because when you subtract something from something, you got to find out what am I subtracting from? What am I decreasing from? That is the sum, which means addition, of these two. So the first thing we got to do is write 2z squared plus 3z minus 7 plus a negative 4z minus 2z minus 3, negative 4z cubed, excuse me, minus 2z minus 3. We're going to sum that up first and then subtract the negative 3z cubed minus 4z plus 7. Again, pay attention to the numbers in front of our parentheses so we can simplify. So we've got a 1 here, 1 there, and a negative 1 there. And we're going to distribute that 1. When I distribute the 1 in the first one, what happens to our parentheses? Exactly, absolutely nothing. So I end up with 2z squared plus 3z minus 7. It's the identity. It stays the same. Then minus 4z cubed minus 2z minus 3. But what does this negative 1 do to the inside? Can you, exactly as you imagine it, it changes the sign. So negative times a negative becomes a positive 3z cubed. And you got to share it to everything. That becomes a positive 4z and a minus 7. People get messed up not paying attention to details. You have to pay attention to details. Again, you have to pay attention to what? Details. So let's go to work. What are we going to do now? Take a gander. combine like terms. So let's combine like terms. So if I look at, I see my highest power here is cubes. So if I take the negative 4z cubed and a plus 3z cubed, that gives me a negative z cubed. I'm done with that. I'm going to cross it out. Now I'm moving on to the next one. I've got z squared. Well, that's the only one I got, which is plus 2z squared. I don't need to play with that. That's just it. Now we got z's. So I got 3z. Now, did I write the problem out right? Because I do have issues. Yep, I did. 3z minus 2z plus 4z. Well, 3 minus 2 is 1, plus 4 is plus 5z. Cross it out. And then minus 7 minus 3 minus 7, which is just a minus 17. And there we go. That's it. And that's it. Any questions over that? Any questions? Well, you would have to ask me questions during our virtual office hours. Guess what? I am done with 5.45. Let's move on. I think I'm going to try to do 5.6 right now. I did 5.4. Usually, I only did 2 sections last time. Let's try for 3. Let's see how we come out. 5.6. You can always stop in the middle. Let's see how it goes. Stop. 5.6. Multiplying polynomials. 5.6. Multiplying polynomials. 5.6. Multiplying polynomials. Well, to multiply polynomials, we want to start off first by talking about a monomial times a monomial. Mono e mono. Monomial times monomial. When you multiply polynomials, when you do monomial, you want to multiply your numbers first. Do your numbers first. And variables second. Using exponent rules. So that whole exponent rules things that we had to do at the beginning of this chapter literally was mainly for where we're going now. We're going ahead and we're talking about multiplying polynomials. So we have to talk about exponent rules, and we needed that to be able to do this. So let's do number 22 to get us ready and get us going. 22 says a negative 5x to the third y to the sixth times 2x squared y squared. So let's see. If I do my numbers first, I get negative 5 times 2. Well, negative 5 times 2 is a negative 10. Do we agree? Oh, you can't even see it. I'm sorry. Negative 5 times 2 is a negative 10. And then let's do our variables. Well, I've got x to the third, and I got x squared. So x to the third means x, x, and x. X squared means x and x. So what do? How many x's I got now? 5. We add the exponents, so I end up with x to the fifth. Do y'all remember that? We just did it back in 5.1. I know that was 5 sections ago, but the rules stay the same. Y to the 6th times y squared is y to the 8th. And that is my answer. Negative 10, x to the 5th, y to the 8th. Okie dokie. Let's move on from that. Let's look at monomial times a polynomial. Let's do monomial times a polynomial. Let's do monomial times a polynomial. For monomial times a polynomial, you want to think distribution. And actually, when we get to polynomial times polynomial, you can think of it that way too. But it's distribution we want to think about. So, here we go. Let's do number 28. Negative 6s times s squared. Remember, I don't like s's, so let's change it to x. Let me start all over. Negative 6x times x squared minus 3. So we're going to distribute. Remember, we're going to distribute to figure this out. So I'm going to draw my arrows because, you know, I like to draw arrows to make sure I don't forget to do both of them, because some of us like to multiply the first one and not like to multiply the second one. So negative 6 times 1 is just a negative 6. X times x squared, remember we add exponents, so that becomes x to the third. Rewind it if you need to. If you got lost with what I'm saying, you know I talk fast. So if you need to remember and re-energize or re-figure out what I'm saying, rewind, push play. Rewind, push play. Rewind, push play. There's nothing wrong with watching something over and over again. Okay? Because you can't ask me right at this second, but you can always send me. We can talk during virtual office hours on the discussion board. So let's take negative 6x times a negative 3. Negative 6x times a negative 3 gives me a positive 18x. And there we go. That's it. Okie dokie. Let's try number, that was 28. Let's go ahead and do number 40. What does number 40 say? Well, it wants us to find the area of a parallelogram. It wants us to find the area of a parallelogram. By the way, I'm on page 401. I might not have said it, but we're on page 401. I'm sorry for not saying it. We're on page 401. We're looking at an area of a rectangle. They gave us a rectangle. I know how I am about drawing. I really don't like drawing because I don't do well. I got W yards for the width and then 8W plus 1 yards for the length. And we want to find the area. Well, we know area is equal to length times width. So essentially we're going to have W times 8W plus 1. Well, remember, we got to distribute. Same math. Math doesn't change. Distribute. And we end up with 8W squared plus W as our product. And our units is square yards or yards squared. All right. All right. So that is how to multiply a monomial times a monomial. Let's do a binomial times a binomial. And again, let me remind you, I would pause it and try it first. Do not just do it with me. Literally, on some of them, pause it and try it first. Now, there are two ways to do a binomial times a binomial. We can do distribute. And then the second way that we can do it, we can do what we call FOIL. So I'm going to do both. I'm going to distribute the first one because we already know how to distribute. And then the second two, I'm going to FOIL because that's something we're used to doing. We've heard FOIL in high school or wherever else you were that you might have heard FOIL. Let's do number 42. I'm going to distribute this time for 42. And I've got a plus 4 times a plus 5. Remember, binomial times a binomial is 2 terms. So 2 terms times a 2 term. So when I distribute, essentially a has to go to this and a has to go to that. So that means a times a is a squared and a times 5 is 5a. And then, oh dear, dropped my pen. Then 4 goes to a and then 4 goes to 5. So I end up with plus 4a plus 20. What do you think I'm going to do now that I've distributed and got rid of my parentheses? What would we normally do when we simplify and we've distributed and got our parentheses? Yep, you've guessed it. We combine like terms. So let's combine like terms. If we combine them, then we end up with a squared. That stays the same. 5a plus 4a is 9a. And then plus 20. So that's what we end up with. We end up with 5a plus 4a, which is 9a, plus 20. Now some of you are saying, Miss B, this is my section. I understand this stuff. And some of you are saying, what in the world have you got me into? But that's okay. We're going to make it. FOIL. You might have heard of FOIL. FOIL, where F stands for first, O stands for outer, I stands for inner, and L stands for last. And I get to introduce you to my math boyfriend that I have. And you might say I'm really lonely because I have this math boyfriend, but that's okay. It's my math boyfriend, so I don't want to hear it. Hello. Here we go. Let's do number 44. We're going to do FOIL. Now, essentially, FOIL and distribution is pretty much the exact same thing. We just have certain letters to help us organize it a little better. But they're the exact same thing. So I'm going to zoom out a little bit so we can actually get a little bit more sight on the paper. Let's take n plus 8 times n minus 10. So, actually, I'm going to do it a little bit bigger so that way we can really see it. I really want to introduce you to my math boyfriend. So let's do that. So if we do that, we start with first. Well, first, the first one in the first spot is the n times the n. Oh, I keep dropping my pen. So if I do n times n, that is in the first spot. So that's n squared. Then we move to O, the O spot. O is outer, so the outside. Okay, I don't know why it's dinging. I don't know what's going on. Here's the O. And so we end up with n times negative 10, which is a negative 10n. Then we move to the inner. There's the inner. And so here's the inner. And we have 8 times n, which is 8n. And then we move to the last. Here's the last. And I hope you can still see it. Running out of room, which is 8 times negative 10, which is a negative 80. That is our n. Now, let's combine like terms. And I'm going to combine like terms and add these up. End up with n squared. Yes? Then negative 10n plus, well, let's just write it down. Minus 10n plus 8n minus 80. Yes? And then I'm going to combine like terms. Combine like terms, if I combine them, then I end up with n squared minus 2n minus 80. And there's our problem. You might be sitting at home saying, Miss B, I do not see your math boyfriend. What in the world are you talking about? Well, let me introduce you to him. Check out his shades. Can you see him now? Hello. Okay, maybe it's real lame. Sorry. All right. So let's put this into action. Let's try it again. I'm only going to write this out like this one time. Keyword. How many times I'm going to write it out this way? Once. I'm never going to do that again. Ever again. So make sure that you rewind, restart if you need to, because I'm not writing that out ever again like that. So let's go to work. Let's try number 52. I'm going to go straight to it and multiply. Are you ready? Let's do 8t minus 1/2. Miss B, you done lost your mind. You done put fractions on there. We can handle it. We can handle it. If we got to write it on the side. So we start off with first. So first is 8t times 4t, which is 32t squared. Because t times t is t squared. Now we're going to do outer. Outer is 8t times a negative 5 over 2. We'll put the 8 over 1. Doesn't the t, 2, and the 8 cancel? It becomes a 4. Yes? So I'm left with 4 times 5, which is a negative 20t. So I get negative 20t. Because the t goes along for the ride. Now let's do inner. Inner, negative half of 4. Well, half of 4 is 2, so negative would be negative 2, and then the t goes along for the ride. Then last, negative half and a negative 5 over 2 is a plus 5 over 4. And I hope you tried this before I did it. I hope you pushed pause and tried it before I did it. So let's combine like terms. End up with 32t squared minus 22t plus 5 over 4. It wasn't that bad. I speak for myself, huh? All right. Just like I can multiply horizontally, I can also multiply vertically. And so we're going to deal with that when we talk about poly times a poly, or a polynomial times a polynomial. So before we did a binomial times a binomial, we did monomial times polynomial, we did mono times mono, but this time we're going to do polynomial times a polynomial. Sometimes there'll be a binomial, sometimes there'll be a polynomial times a polynomial. We'll see how it goes. We're going to start off doing it horizontally. So we're going to start off horizontally. Remember, when we do this, essentially what we want to do is we want to distribute. Essentially we want to do what? Distribute. Distribute each one. Let's do 64. 64 is going to be kind of long, so make sure you have some room. 64 is going to be kind of long, so make sure when you're writing in your notes and you're writing this down, you have some room. I hope you're not just watching it and think you're just going to learn by watching. Bless your heart. Oh my goodness. You're not going to learn by osmosis. We learn a lot of times by doing. Some of you might get it by just watching, but a lot of us, we need to learn by doing. So make sure that you are doing while we're doing, and we do it together. So let's go to work. I'm going to distribute. I'm going to start off with w squared. I'm going to distribute w squared to everybody. When I do that, I end up with, and I'm going to do it in the color that I distributed it with. I get w squared times w squared is w to the 4th. W squared times a negative w is a negative w cubed. W squared times 3 is plus 3w squared. Now when I do the next ones, I always like to line them up. So essentially I'm doing like horizontally and vertical addition and subtraction together at the same time. But this is just the way I like to do it. Let's do w times that. Now we're going to distribute that w. There we go. When we do that, we end up with w cubed, and I'm going to put the plus w cubed right up underneath it. Then we end up with a negative 9w. Well, that doesn't have anything to go under, so it's got to go to the right. And then we end up with, no, we didn't. That was bad math. Oops, 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 oops. W times a negative w is a negative w squared. Miss B made a boo-boo. And then w times 3 is 3w. So there's the plus 3w there. Oops, there's going to be a lot of space, but it's going to be okay. All right, I made a boo-boo. I make them. I'm a human being. I make mistakes. Okay, so let's do negative 9. Let's take negative 9 times w squared. So I end up with a negative 9w squared. Let's take a negative 9 times w. So I end up with a negative 9w. There's that negative 9w. I did it at the wrong time. And then we're going to do negative 9 times 3, which gives us a negative 27. So oops, I didn't line it up right on the end. So now I'm going to combine like terms, which essentially is just adding. So let's draw a line. And I'm going to go left to right because it's much easier. So w fourth plus nothing is just w to the 4th. Negative w cubed plus w cubed, they cancel out. Say goodbye. 3w squared minus w squared minus 9w squared. Well, 3 minus 1 is 2. Minus 9 is a negative 7w squared. And maybe you want it lined up better. So negative 7w squared. I'm getting nervous for some reason. I don't know why. 3 minus 9 is a negative 6w. And then minus 27. And that's that. And that's my answer. Is there any questions over that so far? We only got 2 more questions for this section. You think we can make it? I think so. Let's try to make it through this section. Let's go ahead and try to make it through this section. I'm going to pick up this pencil one more time. I was getting butterfingers for some reason. I don't know, but I was getting butterfingers for some reason. Let's go. Let's try number 68. Let's do number 68. Number 68, we're going to do this vertically this time. So now we're going to talk about vertical multiplication. And to talk about vertical multiplication, I'm going to talk about old school multiplication like you learned it when you were in elementary school. Let's see if we can remember how to do this. Let's take x squared minus x plus 1 times x plus 1. And we're multiplying. And we're not necessarily lining them up. That's not what's going on. Essentially what we're doing is we're lining up like term to term. Not like terms, but just the number of terms. It doesn't necessarily have to be the same term. Just the number of terms. It just happened that this is the same like terms. But it doesn't necessarily have to be it. It just has to be the term that it is. Let's go to work with this so we can see what's going on here. Let's take 1, 2, 3 times 1, 2 on the side as a memory of how to multiply. Let's go. When we normally do 2 times 3 first. 2 times 3 is 6. When we do that first, well, guess what we're going to do over here? Then we would do 2 times 2 and then 2 times 1. Same idea. We would do 4 and then 2. Same idea over here. We start off with 1 plus 1. 1 times 1 is plus 1. 1 times a negative x is a negative x. 1 times x squared is x squared. And we did the first one. Then we would move and we would add a space, right? Or either put a 0 there or put an x, whatever your teacher taught, if you remember. And we would do this term. 1 times 3 is 3. 1 times 2 is 2. And 1 times 1 is 1. Same idea, come over here, but instead of having to add a 0, we just line it up under like term. We have x times 1 is x, so we're putting it under the like term. X times negative x is negative x squared. Remember that was a positive x. Negative x squared, and then x times x is x cubed. So x times x squared is x cubed. Okay? Now that we have done that, what would we normally do over here? Well, normally, what would we normally do? We would normally add down. So we would get 6, 7, 4, and 1. Is that right? Well, guess what we're going to do over here? The exact same thing. We're just going to add down. So we get 1. The x's cancel. Yes. These x's cancel. And we're left with x cubed and a positive 1. And that's how it multiplies out. Is there any questions over that? Well, I can't really ask you if there's questions over that. But that's essentially what it is. I hope that you can rewind, restart it to make sure you understand what's going on. Let's do number 72. Now, keep in mind, you do not have to do it vertically. You don't have to do it horizontally. I want you to do it the way that works for you. Don't care how you do it, just do it. So let's do number 72. Negative 2r times r plus, instead of x's, I'm going to put an x, times r plus x. Order of operations tells me normally we would multiply first with the parentheses. Am I right? There's really no way to do this one. It's up to you how you do it. Doesn't matter. But I'm going to do my parentheses first because it's FOIL. I can do that really quickly, and then I can move on to distributing that 2r. But you don't have to do it that way. You can multiply the 2r first, and then the r, and then times that by r plus x. But this, to me, is the most simplistic way to do it. I'm going to go r FOIL, so I'm going to do r times r is r squared. Remember, I'm putting that parentheses because we're not adding, we're multiplying. Got this negative 2r still in the front. Then the outer, which is plus rx, inner, plus xr, and then last, plus x squared. Well, rx and xr are exactly the same thing. Remember, commutative says a times b is the same as b times a. That's the commutative property. So if that's the case, then that means these two combine to be 2rx. And then you've got your r squared, and then you got your x squared. So now, what do you think I'm going to do next? You got it. I'm going to distribute. So we're going to have negative 2r times r, so this is a mono times a polynomial now. So I'm going to go negative 2r cubed. So we add exponents. Negative 2r plus, and then negative 2 plus times a positive 2 is a negative 4. Then r squared, and the x stays along for the ride. And then negative 2 times a positive 1 is a negative 2. And then r x squared. And that is my answer. Okay, we have finished 5.6. I do hope that now, I do know that now you should be able to do quite a bit of, actually I think a whole section of Chapter 5's web assign. So you should be able to go through and do your web assign assignments starting now. Again, we will be online for online office hours and etc. information if you need help on any of your homework problems. Thank you so much. Have a wonderful day.